So this is explain the difference between different chemical bonds and interactions, ionic, covalent, hydrogen, and van der Waals, and give examples of each. So we're going to talk about 4 different kinds of chemical bonds and interactions, from strongest to weakest. But first, let's back up and talk about different properties of atoms. Atoms have all sorts of different properties and characteristics that determine how they interact with other atoms. One common property of all atoms is that they like to be at the lowest energy state possible. If you remember from earlier objectives, which talked about the structure of atoms and about atomic orbitals and valence electrons, you'll remember that electrons are buzzing around the nucleus in orbitals, which are also sometimes called electron clouds or shells. And the further away electrons get from the nucleus, the higher their energy level. So remember that by nature, atoms will try to be at the lowest energy level they possibly can. And this property it will influence what bonds form between atoms. And another property that determines how atoms interact with one another and form bonds is electrostatic forces. These are forces felt between charged particles. A very basic way to think about chemical bonds is like charges repel and opposites attract. So positive repels positive and negative attracts positive. And remember, protons are positively charged and electrons are negatively charged. So now that we have some background on some different properties of atoms, we can talk about the specific types of bonds and interactions there are between atoms and molecules. So you can see this graphic here showing the weakest of intermolecular forces to the strongest of intramolecular forces. And we're going to talk about each one of these. So first one we'll talk about is the strongest, which is ionic bonds. So with ionic bonds, the key word is transfer. Ionic bonds are formed when electrons are transferred from one atom to another. And this is an illustration of that. So ionic bonds usually form with atoms that have loosely held outer electrons. So these atoms will drop electrons easily to become positive ions. So when a positive ion comes across a negative ion, the opposite charges are attracted to each other and they will bond if they can. So an example of this is sodium chloride, which is also called table salt. So sodium is a metal that is not very electronegative. So its outer electrons are held very loosely, and it can give up those electrons pretty easily to become a positively charged ion. Chloride, on the other hand, is a halogen, which is very electronegative, and it likes to hold on to its electrons very tightly. So when sodium and chloride are together, they can form an ionic bond. Sodium gives up an electron to become a positive ion, and chloride picks up that electron from sodium and becomes a negative ion. So transfer of electrons, ionic bond. Ionic bonds are extremely polar and much more polar than covalent bonds, which we'll talk about next. So next, covalent bonds. And the keyword here is share. Covalent bonds are formed when 2 atoms share electrons. So covalent bonds are usually formed by 2 elements that are more strongly electronegative, which means that the atoms hold their electrons so tightly that they're more likely to share rather than one atom transferring its electrons to another. Put another way, electronegativity is the strength of an atom to attract shared electrons. And the property of electronegativity can help us understand the different types of covalent bonds. Within the umbrella of covalent bonds, there are polar and non-polar covalent bonds. When there's a difference in electronegativity between 2 atoms that are bonding in a covalent bond, the electrons will like to hang out or be nearer to the more electronegative atom. So let's give an example. So first, here's an example of a polar covalent bond, water. Water, or H2O, is made up of 2 hydrogen atoms and 1 oxygen atom. Oxygen is the more electronegative element, so it attracts electrons. And since, remember, electrons carry a negative charge. That means there's more negativity on the oxygen side of H2O and more positivity on the hydrogen side of H2O. And this is called polarity. So this creates a polar covalent bond. So polarity is created when electrons hang out near one atom more than the other atom in a molecule. And then an example of a nonpolar covalent bond might be chlorine gas, which is made up of 2 chlorine atoms. So in this molecule, the 2 chlorine atoms are identical. So there's no difference in electronegativity between the 2 of them. So the electrons are evenly shared. There's no partial positive or partial negative charge in this molecule. So the next type of chemical interaction is hydrogen bonds. The key words to remember here are partial positive and partial negative. Hydrogen bonds are a type of interaction that occurs between molecules that have hydrogen in them. It's also important to take note that the term hydrogen bond is not, the hydrogen bond is actually an intermolecular force, not an intramolecular force. So it's 2 separate molecules interacting with each other rather than 2 atoms bonding within a molecule. Hydrogen atoms are not very electronegative. So when hydrogen is in a molecule bonded to another more electronegative atom, the electrons will like to hang out nearer to the electronegative atom and further from the hydrogen. So let's take water as an example again, H2O. But instead of looking at the covalent bonds within the molecule between this hydrogen and this oxygen, now we're going to look at the interactions, these hydrogen bonds between molecules. So the difference in electronegativities between hydrogen and oxygen creates a partial negative side called a negative dipole on the oxygen, and a partial positive side called a positive dipole over on the hydrogen. The electrons are more likely to hang out on the electronegative atom, the oxygen, and less likely to hang out near the hydrogen. So now these dipoles within each molecule cause the individual molecules to interact with each other and arrange themselves so that the negatives are attracting the positives. And that is the hydrogen bond. So to summarize, the hydrogen bonds are loose bonds or interactions resulting from partial positive and partial negative dipole interactions. Hydrogen bonds are weaker than ionic and covalent bonds, but stronger than van der Waals interactions, which is the next one we'll talk about. So van der Waals interactions, which are also called London dispersion forces or induced dipole interactions, are the weakest of the intermolecular forces. But they are still very important because they are the most ubiquitous. Every single molecule has this type of force to some extent. So van der Waals interactions are when electrons interact in nonpolar molecules, between nonpolar molecules. So you can see in this illustration right here, these circles represent different molecules. And as the electrons in this nonpolar molecule buzz around in their valence shell, there might be at any given moment a positive side or a negative side, just as the electrons kind of ebb and flow. And when those dipoles occur, then the partial positive dipole will be attracted to a partial negative dipole. And this is a weak interaction, but even though van der Waals interactions are weak, altogether in a substance, they have a very significant effect on the properties of that substance. Like for example, van der Waals interactions are responsible for bulk properties of substances like boiling and melting points.